Hello, welcome, ladies and gentlemen. We are going to look at linear kinematics. It's all under the application of differentiation. Is that okay? For the linear kinematics, it's fall under mechanics. Okay, when we move to mechanics, but it's also under differentiation. We are going to look at three parameters here. First, we are going to look at displacements. Okay, in some books, you see it as position. So they are the same. You don't see displacement and you see position is the same. We also looked at velocity. Velocity, is that okay? Then we also look at the acceleration. So now, let's deliberate on this. First, we have displacement or position. What do we mean by displacement or position? When we say displacement, is the distance covered in a specific direction. Is that okay? That's why normally we say displacement is a vector quantity, because when you cover the distance, you cover with a specific direction. Good. Now, you also have velocity. Velocity. In fact, velocity is the displacement with respect to time, or the position with respect to time. Is that okay? I don't want to say the distance with respect to time. No. Speed is distance with respect to time, but velocity is displacement with respect to time. So we are saying that velocity is what? Displacement with respect to what? Time. Is that okay? And also, acceleration is the velocity with respect to time. So for acceleration, we have is what? Velocity with respect to what? Time. Time taken. So these are the definition. The displacement is the distance covered with what? A specific direction. And the velocity is the displacement taken with respect to time taken, and displacement with time taken. Then the acceleration is the velocity with time taken. Now here, we are going to apply the differentiation on this. And when we say differentiation, you know that differentiation simply means change, rate of change, okay? Rate of change. At the beginning, I told you that differentiation is when we find uh, the slope, right? Yes. So when you say differentiation, simply you are saying slope. But it's also the rate of change. When you say rate of change, means you are changing with respect to time. So when the velocity here, you see that we are changing the displacement with respect to time. So it's a rate of change. Now, if I need velocity, then we are saying that the velocity will be the change in what? Displacement. Normally, we represent the displacement by s, okay? So it will be the change in displacement over the change in time. So ds dt, okay? ds dt. So change in displacement with respect to change in time. So the time here is bringing the what? The rate. Okay. Now we also have acceleration. For the acceleration, is also change in velocity. So with respect to what? Time. Is that okay? So what it means is that, let's say if I have the displacement, which is s, and I want velocity, all that I need to do is to differentiate the displacement. Once the displacement is differentiated with respect to time, I get what? Velocity. And if I differentiate velocity with respect to time, I get what? Acceleration. So you should know how these things work. Is that okay? Because we are going to use them in doing our calculations. Good. Now let's look at the first example. Okay, now let's look at our first example. A particle move along a straight line such that after t seconds, so we should take note of some of the things here. After t seconds, the distance moved s, that's the distance, that's abbreviation for distance, s meters, is given by s equals t cubed minus 9t squared plus 15t minus 3. Find I, the velocity and acceleration of the particle in terms of t. That's the I. The value of t when its velocity is 0. I. The acceleration after 3.5 seconds. IV, the time at which the acceleration is 6 meters per second squared. Is that okay? In fact, the unit for acceleration is meters per second squared, and velocity is just meters per second. So you should take note. And distance or displacement is also just meters. Okay. So let's see how we can solve this. First, you have to be able to identify the distance or the displacement given. So you have t cubed minus 9t squared plus 15t minus 3. Is that okay? So this is what is given. Here, we want to, the first thing says we should find the velocity and the acceleration of the particle in terms of t. So I said at the beginning of the video that if you want to find the velocity from the displacement or the distance given, all you need to do is to differentiate it. That gives you the velocity. So velocity will be equals to the s the t. Is that okay? So my velocity is equals to, now we are differentiating this. If I differentiate this, this will give me 3t squared minus 18t plus 15. So this is my velocity. Then I'm tasked to also find, so this is the I, okay? Also find in terms of the acceleration. So my acceleration will be what? Dv dt. So acceleration is equals to, now I'm going to differentiate this instead, not this. Okay, so dv dt, if I differentiate this, 3t squared, if you differentiate, it gives you 6t. If you differentiate this one, it gives you negative 18. We know that if you differentiate a constant, you get 0. Differentiate a constant, you get 0. So this is for what? The I. So the acceleration is A equals C, 6t minus 18. Velocity is 3t squared minus 18t plus 15. So this is very simple. If you want a velocity, you differentiate it from the distance. If you want acceleration, you differentiate it from what? The velocity. And that is it. So you are done with the I, okay? Now let's move to the II. The value of t when its velocity is 0. So you want to find the value of t when its velocity is 0. So that is II. The value of t when its velocity is 0, okay? Meaning that velocity is equal to what? 0. So we want to find the value of t. So where's our velocity? This is our velocity. So our velocity was given as 3t squared minus 18t plus 15. So if the velocity is 0, it means wherever I see v, I should put 0 there. So I'm going to have 3t squared minus 18t plus 15 is equals to 0, okay? Now, if you look at this one, I can divide through by 3 because 3 can go into 18, can go into 15, so it's a common term. So if I divide through by 3, I'm going to have t squared minus 3 going into 18 6 times, so 6t plus 3 going to 15 5 times equals 0. I hope this is right. Good. So this is quadratic equation. So for the quadratic equation, you can all solve it. If you solve this one, all you need to do is that you look for factors of 5 such that when I add them, I'll get negative 6. If I multiply the same two factors, I'll get 5. And those two numbers are negative 1 and negative 5, right? So, negative 1 times negative 5. Negative 1 times negative 5 will give me positive 5. Negative 1 plus negative 5 will give me negative 6. So these are the two factors. So it means I'm going to have t squared minus 6 minus 5t minus t plus 5 equals 0. So here if I factorize t out, what do I have? I have t minus 5. Then here too, t minus 5 equals 0. T, here it means there's 1 here, so t minus 1. Okay. Then t minus 5 here equals 0. Is that okay? Very good. Let me clean this side up. So looking at this one, we have our t minus 5 to be equal to 0, or t minus 1 is equal to 0. It means that our t is 5 seconds equals 1. Is that okay? So the value of t when its velocity is 0 is t equals 5 seconds or t equals 1 seconds. Is that okay? So that is what we have for the second one. Now the third one is saying that the acceleration after 3.5 seconds. So that's I. Acceleration after 3.5 seconds. The formula for the acceleration was 6 t minus 18. Okay. So if time is given as 3.5 seconds, it means that we should substitute the 3.5 seconds here. So let's clean this side. So a equals 6t minus 18. My t, so this is improper. Sorry, mixed fraction. So we change them to improper fraction. So this is going to be 7 over what? 2. So my a will be equal to 6 multiplied by 7 over 2 minus 18. So it will be 2 can go into 6 3 times. 3 times 7 is 21 minus 18, which will give you what? 3 meters per second squared. Is that okay? So the acceleration after 3.5 seconds is what? 3 meters per second squared. Then the last one, the time at which the acceleration is 6 meters per second squared. Where is our acceleration? Our acceleration is still 60 minus 18. So when acceleration is 6 meters per second, it means wherever you see a, we put 6 there, because 60 minus 18. So grouping like terms, we have 60 equals 18 plus 6. So 60 will be equals to 24, right? You divide here by 6, here by 6, which means that our t will be equals to 6 can go into 24 4 times, so 4 seconds. 4 seconds. So this is the answer to the first question. Let's look at the second question. All right, let's look at the second example. A car starts from rest. So the keyword rest and moves a distance s meters in t seconds, where s equals 1 over 6t cube plus 1 over 4t squared. First one, what is the initial acceleration? Second, what is the acceleration at the end of 2 seconds? So this is the question. You can pause the video and try your hands on it. Okay. So now let's start. Here the distance has been given as 1 over 6 t cube plus 1 over 4 t squared. So once we need acceleration, we need to differentiate the to get velocity. Then after getting velocity, we differentiate to get what? Acceleration. So my velocity will be equals to the s over what? The t. So it means that my velocity will be equals to, if I differentiate this one, here will give us what? 1 over 2 t squared plus 1 over 2 t. I hope you understand this, because if you differentiate, the 3 will come here, right? So it will be 3 over 6. That gives you 1 over 2. The 2 comes here, 2 over 4. That gives you this. Now we need um, acceleration. You know, acceleration means you should differentiate what? Velocity. So if I differentiate velocity here, these 2 come here, that will give you t. Because 2 over 2 is 1 minus this. You know how to do it already. If you don't know how to differentiate, go to my YouTube channel, Dramani Online Mathematics. If you are there already too, you search, or you go to my Play Store, my playlist, my playlist, to look for the solution, how to solve these things. Plus, if I differentiate this will give me half. Okay, so this is what I have. It means that acceleration is this. Is that okay? So if this is an acceleration, what next? Or what are you going to do next? The question says, what is the initial acceleration? So initially, the car wasn't moving, right? So there was no time used. It means that at initial time is given as what? 0 seconds. There's no time used. So my A will be equals to 0 plus half. So my acceleration will be half, which is the same as 0.5 meters per second squared. So that is for the acceleration at the initial point. 2, so that is I. What is the acceleration at the end of 2 seconds? So at the end of 2 seconds, that means at that time is given as what? 2 seconds. Okay. So when I come there, acceleration is equals to t, which is now 2 plus half. So 2 plus half is the same as 2.5 seconds. Is that okay? So this is simple way of solving this question. Thank you very much. Let's move to another example. Okay, so this is a trial work. A ball is thrown vertically upwards and its height after t seconds is s meters, where s equals 25.2 t minus 4.9 t squared. Find its height and velocity after 3 seconds. Okay, now just like I said, this s here is a distance or displacement. So if the question asks you to find its height, it means that just substitute this seconds into this, and that gives you the height. Okay, and velocity after 3 seconds means you know what to do. When you, after differentiating it, you substitute. And I said that when it is momentarily at rest, means that at the point where the car stopped or the particle stopped, that means the velocity at that point is 0. So you know what to do. So please do this and leave the answer in the comment section. Thank you very much.